going to do some exam type questions today. So I found a few different questions for you that I'd like to go through. The first question is sort of fairly straightforward, I would say, but it's nice because it kind of goes back to what we were doing about the parabola. And I know that initially there was quite a lot of confusion about restricting the domain and what that meant and how we did it, et cetera, et cetera. So yeah, just to remind everybody, when we, oh, this is the question straight out of an exam, Simpiwe. It's an exam question. So yeah, your teachers used an end of year exam question to give you, which is actually fair, because this is the kind of thing that you would be expected to be able to do at the end of the year as well. All right, so just a reminder, when we are talking about the quadratic function, when we do the inverse of a quadratic function and we have not restricted the domain, our inverse is not a function. Okay, it's a many to one relation. So what they've done here is that they have restricted the domain to where x is negative, so either 0 or negative, in order for the inverse to also be a function. They're actually going to ask us questions about that. You're going to see that. All right, so just to put things into perspective, this is essentially what you are looking at. Okay, so let's draw a set of axes just very quickly. Just drawing it very small, and imagine you have got a parabola that does that, and then you have got a parabola, the inverse of this, which does this. Okay, what you are looking at here, all right, is this. This is f. Okay, that's this pink bit over here. That's what you're looking at. The bit in purple, the inverse, is that bit over there. So that's this bit here. So that's essentially what you're looking at. What they've done is that they've got rid of the rest of this. Okay, so we can't see the rest of this. That's all they've showed us. Okay, but to put things in perspective, that's what it is that we are looking at. Okay, so we're looking at one arm of the parabola, because the domain has been restricted, and then we are looking at its reflection over the line y equals x. The first question that they ask us, the graph of f of x equals ax squared is drawn. The graph of f to the minus 1 is also drawn. The point P, minus 6 and minus 12 is a point on f, and R is a point on the inverse. The first question that they ask us is the inverse a function? All right. So Simpiwe, what did you say in your test yesterday? Did you say yes, it is a function, or did you say no, it's not a function? I agree. Okay, well, that's perfectly correct. Yes, it is a function. Now we have to give a reason because they want us to motivate our answer. So why? What could we say here? You're all correct. Yes, it's a function, but why? Why is it a function? Yeah, perfect. Okay, so it passes the vertical line test. Is there anything else we could say? Absolutely. There's someone was using the word unique. I like that. Yes. Okay. So there is a unique y for every x. Lovely. That's another way of saying that it is a one-to-one function. So absolutely. So you could say there is a unique y to each x, or you could say that it is a one-to-one function. So there are, sorry, look at me here, leaving out the word two. One to one function as well. Okay, so any of these reasons would be suitable. So a mark for yes and a mark for the motivation. All right, someone had a hand up. Is there a question? Kagiso, okay, go for it. What's your question, Kagiso?
Hi, ma'am. Can I please ask, which, like, where is this question from? Like, what paper is it from? If you know.
I don't actually know off the top of my head, to be honest with you, but it'll be one of the papers that are on the department's website. So if you go and have a look at their past papers, you would find it there. Sorry, I don't know off the top of my head.
Okay, no problem, ma'am.
Okay, all right. Then in the next question, they say to us, if R is the reflection of P in the line y equals x, write down the coordinates of R. So what do you guys think? What are the coordinates at R? Anyone know? There we go, guys. Good. Well done. Lovely. Very nice. Perfect. Okay. So the x coordinate would now be -12 and the y coordinate would be -6. Okay, so remember an inverse is the same as reflecting something over the line y equals x. So if these two graphs are inverses of one another, then if R is the reflection of P, we would have to switch the x and y coordinates around. Excellent. All right, so there would be one accuracy mark for our answer there. Good. Right now they want us to calculate the value of A. So just to remind you guys, A, they're talking about this A here in front of the x squared. So f of x equals ax squared. They want us to solve for A. So that essentially takes us back to grade 10. All right. How are we going to solve for A? What are we going to sub in? We're going to sub in point P. Quite right. Okay. So Mpaseka, all right, it's because f to the -1 is the inverse of f. These two graphs are a reflection of one another about the line y equals x. So when we reflect over the line y equals x, x becomes y becomes x. That's why at R, x is -12 and y is -6. Okay, no problem for you. Welcome. Glad you were able to join us. All right, let's just see what's going on in the chat here, and then I can. Nizole, you saying A is equal to 2. Nizole, I don't agree with you that A would be equal to 2. And the reason I don't agree with you is because this original function f is part of a sad face parabola. So whatever A is, it would have to be a negative number. Right, but we can actually calculate, there we go, that looks better. Yes, I agree, -1/3, that's what I would get as well. Good, nice guys. So this is how we would have done that question. Everybody else, this is where their answers are coming from. Right, we're going to sub in P because P lies on F. So f of x is y equals ax squared. So y is equal to -12 when x is equal to -6. So that would give us -12 is equal to 36a. We would divide by 36 on both sides, and that's why a would be equal to -1/3. Good, well done, everybody. Very nice. So here we would get a mark for subbing in and a mark for our answer as well. Okay. All right, so that's question 4.3. Now, question 4.4, write down the equation of f to the -1 in the form y equals. Okay, so anybody know Pinga, sorry. Oh, Mihlali and Pinga, you're asking me to repeat how I got 4.2. Oh, you just didn't square, okay. All right, Nazoli, at least you found your mistake, okay. So if you have your x and your y like this, and here's your line y equals x. If I have a point over here, and let's say the coordinates at this point over here were 1 and 4, and now I want to reflect this point over the line y equals x, I would switch the x and y coordinates around, so it would become 4 and 1. Okay, so what was x becomes y, and what was y becomes x. Okay, so this was originally x, that was y. When we reflect over the line y equals x, they switch around. So that's why this would be minus 12 and minus 6. Okay, we're reflecting over the line y equals x. Okay, now back to 4.4, the equation of f to the minus 1. All right, remember f is the graph of minus 1 over 3 x squared. So if y is equal to minus 1 over 3 x squared, we would need to switch x and y around. In Paseka, I divided by 36 on both sides. So negative 12 divided by 36 is where the minus 1 over 3 comes from. Okay. All right, so we're going to switch x and y. So x becomes minus 1 over 3 y squared. Now I want to make y the subject of the formula. So now I've got to divide both sides by negative 1 over 3, or I can multiply both sides by negative 3. It would give me the same answer. So now we've got y equals negative 3x, sorry, y squared equals negative 3x. And now I need to take the square root. So y would be equal to plus minus the square root of negative 3x. Now, we've got plus or we've got minus. We've got to decide which one it is, right? Our graphs have been drawn in the third quadrant where y is negative, x is negative, but y is also negative. So that means that we would have to choose the negative answer. All right, and that would be negative 3x inside like that. There we go, Kamogelo. Good, good. Y equals negative root minus 3x. Lovely, well done, perfect. How are we feeling, everybody? We feeling good? Thumbs up, thumbs down.
I think that says yes, feeling good.
Cool,
Kagiso
Pinga.
shop also. Fisani also. Nice. Okay.
Okay, all right. So Sihawu, we use logs when we are working with the inverse of the exponential function. So this is a quadratic function. All right, so we're not using logs here. All right, Katleho, y is e minus 3x again. I'm not sure what you mean by e. Did you mean y? I'm not sure. So in other words, what we would have had to do in order to go from this step over here to the one below it, we have to divide both sides by negative 1 over 3. That's why we get y squared is equal to minus 3x. Okay, so Katlejo is because we're dividing, because remember we're trying to isolate y, aren't we? So we're going to divide both sides by negative 1 over 3. Okay, so if you take, because remember in front of the x there's a 1, right? So if you take 1 and you divide 1 by negative 1 over 3, that's going to be the same as multiplying it by minus 3 over 1. So that's why we end up with minus 3x.
Oh, okay, thank you, ma'am. It was a
All
typing
right.
mistake.
Okay, all right, fine,
Okay,
not a
thank you.
problem. Good stuff. Pleasure, 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 pleasure. Okay, so let's have a look at the next question. All right, sorry, it's kind of been squeezed in here a little bit. This kind of relates to what we were doing up here. I'm going to have to rub that off. All right, so now we've been given g of x equals 3 to the x. The first thing that they want us to do is write down the equation of the inverse in the form y equals. So I'm going to let you guys do that because everybody knows how to do that by now. Now we're working with logs Sihawu, okay, because we're working with the inverse. There we go, Kagiso, good stuff. That was super quick. Good, well done. All right, so using logs in the correct way. That's perfect. And now they're asking us another. Yes, good Pigelo, good Kagiso. That's great. Okay, so now in 6.1.2, they tell us we've got the point 6 and 11, and it lies on h of x, which is the graph of 3 to the x minus 4 plus 2. The graph of h is translated to form G. Write down the coordinates of the image of P on G. So again, this is a difficult question. That's okay because they've done a transformation and now they're asking us what were the coordinates that were originally 6 and 11 on H, what would those coordinates be at that same point on G? Right. So in other words, what we are doing here, Matrix, is we are going from the graph of h of x equals 3 to the x minus 4 plus 2, and we're going to G. So we're going to G of x, which is just 3 to the x. So now we have to compare what is happening to x and what is happening to y, right? As we go from H to G. So I'll see if you guys can give me the answer to that. What did they do to X when they went from 3 to the X minus 4 plus 2 to 3 to the X? What did they do to X? So Pigelo
Minused
says
it by 4.
they minused it by 4. Okay, so let me ask another question, all right? When we go from 3 to the x minus 4 to 3 to the x, are we moving the graph to the right or are we moving the graph to the left? From H to G, are we moving the graph to the right or are we moving the graph to the left? You guys are going the wrong way here. Okay, remember we are going from H to G. From H to G. So H is our starting point and G is our ending point. Okay, so be very, very careful. Read carefully, guys. Okay, because they say to here, the graph of H is translated to form G. Okay, so not the other way around. We're not going from G to H. We're going from H to G. Okay, so H is our starting point and G is our ending point. Did we really move 4 units to the right? Okay. Let's just see what you're saying in the chat here. Okay, so H of X, it's 2 units up or down. Because it's plus 2, it's got to be 2 units up. Okay. Yes, Pigelo, it's actually quite a difficult question. All right, you've got to be very, very careful, right? So if we started with 3 to the X, and we had 3 to the x minus 4, then I agree with you. I agree with you. We have shifted the graph to the right-hand side. But because we're starting with H and we're finishing with G, we've actually shifted the graph to the left. All right, so if you think about it this way, right, what you've got here essentially is plus 0, plus 0. So you've gone from minus 4 to 0. So what's happened to x? You have added 4 onto x. You have added 4 to x. Okay, as far as 2 and 0 is concerned, you've gone from 2 to 0. So we've had to minus or subtract 2 from y. Okay, does that make sense to everybody? Kagiso, question?
So, ma'am, is the original graph H, ma'am?
Yes. That is the yes, that is your original graph in this sense. Okay, so this is a trick question because they say to you, oh, here we're talking about 3 to the x. But then what they're doing is that they're working from H to G. All right, so it is. It's like it's You got to read very, very, very carefully. Okay, you're going from H to G. All right, so in order to go from 3 to the x minus 4 plus 2 to 3 to the x, essentially what's happened is that this negative 4 over here has become 0, and that 2 over there has become 0. Okay, so if we were to do anything to our exponent, we're essentially doing something to x. We're either moving the graph left or we're moving the graph to the right. When we add and subtract over here at the end, we're changing y because either we're moving the graph up or we're moving the graph down. Okay, so this original graph was shifted 4 units to the right and 2 units up. So what's the reverse of that? What's the opposite of 4 to the right? It would be 4 to the left. Okay. And if we'd move 2 units up, we would now be moving 2 units down. Okay, so the graph was originally changed to the right. So we've shifted it in the opposite direction, and we've also moved it down. Okay, is everybody happy with that? Exactly. Okay, so Kagiso, so therefore the image of P, all right, we would add 4 onto X, quite right. Okay, so that would become 10, yes, and 10 and 9, yes. There you go. You got it. All right. But yeah, 2 marks, but conceptually quite a difficult question for us to be able to answer. Okay, well done, everybody. That's great. Are we ready to move on to our next question? Okay. Londeka, I'm happy to explain it again one more time. Sure. Okay. Got to read this question very, very carefully before you jump in and start answering it. Okay. They tell us, let's just take that off and let's highlight it again. Okay. They are telling us P is a point that lies on H. The graph of H is translated to form G. So in other words, they are telling you we are starting at H and we are going to G. Okay, so our beginning point is H of X. And H of X is the graph 3 to the X minus 4 plus 2. Right? What we are going to is the graph of G. G of X is the graph 3 to the X. Why does P have the power of 1 when you did the coordinates? Oh, because it's the image of P. So we say this as P prime. Okay, it's the image of P. So that we say P prime, and it means the image of P. Okay, so that's just the notation that we use when we talk about transformations. Okay, so you can have P prime, you can have P double prime, you could have P triple prime, and they would all be translations or transformations of P. Okay, so yeah, it's just the notation. Okay, so let's just talk about this one more time, guys. All right, as I think it was Kagiso was saying, H of X is our original function. We are producing G from it in terms of this translation. So we're going from 3 to the X minus 4 plus 2. So if we consider this particular graph, all right, this over here tells us that it has been shifted 4 units to the right. So what's the opposite of 4 units to the right? It's 4 units to the left. Okay, so when we add 4, we're moving the graph back to the left-hand side again. Okay, the reason why we're doing that is because in order to balance out the negative 4, we need to add 4 onto it. This is what gives us 0. Okay, it's an additive inverse. So the -4 moved the graph to the right, the +4 moves it back to the left-hand side. So essentially what we are doing is we are adding 4 to x. Okay, so that's why we took this and we added 4 to it and we got 10. Then at the end here, all right, we have not shifted this graph up or down. All right, so y is equal to q, sorry, y equals 0 is the equation of the horizontal asymptote. So our x-axis is our horizontal asymptote. Here, our horizontal asymptote is the line y equals 2. So we've gone from +2 to 0. So in other words, we have subtracted 2 from y, subtracted 2 from y. That's why we've started 11 and we've ended at 9. Okay, so what we what we are doing to our graphs is what we would do to an individual point. Okay, so that point would be increased, the x-coordinate would be increased by 4, and the y-coordinate would be decreased by 2. Okay, because that's what they gave us, Lutando. Okay, they gave us this in the beginning. Yeah. Okay, we were given that in the beginning. All right. Are we ready to move on to another question? Okay, there's some
Take
tricky questions.
screenshots. Yeah, like
Yeah.
this, they don't forget.
Ma'am, can you perhaps
Correct.
please?
Yes, Lorato. Sorry, Pagelo, go for it. Yes.
Yeah, ma'am. Can you please get some questions that are kind of like this for more practice?
Yes, absolutely. Okay, I'll have to go and have a look for a few more. I don't think we'll get through everything that I want to do this evening. So yeah, hopefully you'll be able to take down what I have got here. Okay.
Thank you, ma'am.
All right. Okie dokes. Let's have a look. We were talking about this question in the other class as well this evening, so I wanted to do this with you guys too. This is also a little bit of a more difficult sort of question, or certainly when we get down to 6.3 and 6.4, but the beginning bit of it is not too bad. Okay, so again, we're dealing with log graphs, and f of x is what sort of function, Matrix? What sort of function is f of x? Yeah, perfect. Okay, so it's a linear function. So it's a straight line and a log function that they have now combined together. Absolutely. Okay, and they've said to us, first things first, on the same set of axes, sketch the graphs of f and g clearly, showing all intercepts with axes. All right, so this is the first question that they want us to do, is a sketching question. Hopefully this isn't too difficult for any of us to be able to do. All right, so let's get ourselves a set of axes, and then we can talk about how we are going to do this. So there we go. Maybe what I should do here is move this question down a bit. Let's get it out the way. There we go. All right. So how would we draw the graph f of x equals minus x plus 3? What do we need to show the intercepts with the axes. Oh, sorry, all where to. I know I'm also sitting in the dark here. Do we know what the y-intercept of this particular graph is? Of f of x? Do we know its y-intercept? Do we need to calculate that?
Yeah, we can calculate.
Okay, it's 3, exactly. So we're not going to waste our time calculating it. If we want to calculate the x-intercept, what would we do? What would we do for the x-intercept? Exactly, we'd make y equal
Make
to?
it low.
Exactly, Pagelo. Okay, so we make y equal to 0. So again, that's very, very easy for us. Making y equal to 0, we'd end up with negative x plus 3. So that means that x would be equal to 3. Right, so if we now go ahead and go and draw this graph, it's got a y-intercept of 3 and an x-intercept of 3. Maybe they did that on purpose to make it a little bit more confusing. I don't know. And it has a negative gradient. Okay, so it looks something like that. Okay, so let's label the axes, sorry, our intercepts. That would be 0 and 3, and then that point there would be 3 and 0. Okay, cool beans. So that is our linear function done. Now we need to draw our log function. So g of x equals log 2x. It's not going to have a y-intercept. It's only going to have an x-intercept. Does anybody know what the coordinates at the x-intercept would be? They're always going to be this for our log graphs. Anybody know what it would be? That's it. It certainly would be. So yes.
Well done, guys.
Good, guys. That's excellent. Okay, so that's just a matter of learning. Well done. Let's draw this graph. And I'm going to try and draw it the best I can. Okay. And that point over there would be the point 1 and 0. Good. Well done. Okay, so here they would probably give us a mark for the shape, the x-intercept, the shape of the linear function to make sure that it was decreasing and that we had the correct x and y intercept. So it's probably where our 4 marks would be allocated. Is everybody happy with that? We all good? Thumbs up, thumbs down. How are we feeling? Okay. All right. Now, see, there was a hand up. Oh,
Mondeka.
was it
Maybe.
Londeka? Okay, Londeka, go for it. Do you want to ask a question?
Hi, ma'am. Can you hear me?
Hi, Londeka. Yes, I can hear you well.
Hi, ma'am. May you please go back to the first question or to the statement?
Yes, with pleasure. There we go.
Oh, ma'am. So I just want to know how you got the x and y intercept, the x and y
For
coordinates.
which
GX.
graph?
The GX.
For G, okay. So it will always be 1 and 0, okay? So, and that's something that you can learn. The reason for that is this, okay? The inverse of the log function is your exponential function, okay? So the inverse of g of x would be the graph 2 to the x, right? So if y is equal to 2 to the x, and we're talking about the y-intercept, then we would make x equal to 0. So that means that your y-intercept would be at 1. Now remember, what was your y-intercept on your inverse, in this case, is going to be the x-intercept on g. So that's why it's 1 and 0. Okay, because your exponential function is always going to have a y-intercept of 1 when we're talking about inverse functions. Okay, they're not going to shift them and then expect you to work out what the x-intercept is. So if the graph hasn't been shifted up or down, so it's the graph 2 to the x, 3 to the x, 4 to the x, 5 to the x, whatever it is, half to the x, it's always going to have a y-intercept of 1. Okay.
Okay, ma'am. So is that
Okay.
always the
All,
case?
it's always the case. That is always the case.
Okay,
All right.
thank you, ma'am.
Okay, no problem. The next, so I just see there's a couple of other questions. Let's just take those quickly before we move on. So Londeka, we answered your question. Danelle, you're welcome to ask.
Hi, ma'am. Can you hear me?
Yes, I can.
So,
What do you
ma'am,
want
as
to
you
ask?
said, So ma'am, as you said, by the log function, we always get 1 and 0. But when in my class and maths, we would also to find the intercepts of the exponential function and then swap the intercepts.
Exactly. That's exactly right. That's exactly right. So what was your y-intercept on your exponential function is now your x-intercept on your log function. Or what is your x-intercept on your log function is now your y-intercept on your exponential function. Absolutely. Okay. So yeah,
So
quite
ma'am,
right. Mm-hmm.
so ma'am, will they allow us to do this in a exam?
Yes, absolutely.
Okay, thank you, ma'am.
No problem. No problem. All right. So now they want us to write down the equation of the inverse of G in the form y equals. So we would write this as y equals what matrix? Y equals, there we go, Kagiso, good job. So we would write it as y equals 2 to the x. Cool. All right. So here another reason why we're doing this question is because here our original function is our log function and our inverse function is our exponential function. Okay, so it's also nice for us to see it asked that way as well. Now we get into the slightly more thinking type questions. And the first question that they ask us is to explain. We don't see that very often in maths. Explain how you will use question 6.1 and or question 6.2 to solve the equation log base 2 3 minus x equals x. How would we use question 6.1 and or 6.2 in order to solve this equation? All right, so without me telling you, I'd like to hear from you guys what you think we should do with the equation that they've given us. What do you think you should do with it? Essentially, yes, Pinga, you would be solving for x. But the first thing is that before you actually solve for x, they want you to explain how question 6.1 and 6.2 relate to what we're seeing. How does 2 to the x and f of x and g of x tie into this equation? Anybody got any ideas? If you saw, let's just, it does, Pinker. That's a really nice, it does. It is like a combination of the two, 100%. It is, right? Can you see that what's in the bracket here? Look at what's in the bracket here, this 3 minus x. That's the same as that, isn't it? X minus x plus 3. So these two have to be related to one another in some way. The other thing that I want to point out to you is that when something is given to you in log function, think about what that means. Okay, so it's given to you as log base 2, 3 minus x equals x. So when something is written this way, okay, it's the log of the base number equals the exponent. So what I want you to do now is I want you to write base to the exponent equals number. Okay, so now we're going to write base to the exponent equals a number. So how can I apply that to this? What should I write? Anyone got any ideas? Ah, well done, Shisana. Very nice.
Wow, guys, well
Okay.
done.
Excellent, excellent, excellent. So Shisana has taken the base of 2, the exponent of x, and said it's equal to our number, which is 3 minus x or minus x plus 3. Good, Shisana, absolutely. Right, so now we need to look at what it is that we've got. Minus x plus 3 is the graph of f. Okay, so this is f. What's this graph over here, 2 to the x? It is it's g to the minus 1, isn't it? It's the inverse of g. Okay, so f is the graph minus x plus 3, and 2 to the x is the inverse of g. That's how we would work, or that's how we would explain how we're going to use questions 6.1 and 6.2. So 6.2, we're using the inverse of g. 6.1, it's the graph of f. All right, so in other words here, let's just answer the question. How would we use 6.1 and 6.2? So we use the inverse of g and f in order to be able to solve this equation. No, we're not going to do that, okay? The reason that we're not going to do that, Pagelo, is because that lies outside of the CAPS syllabus, right? So what they're doing here is that they're asking you an easy, difficult question, all right? So question 6.4, they now actually want you to solve it, right? So you're looking at this and you're saying to yourself, essentially, if I've been able to rearrange this and get this, how am I now going to solve this equation? There is a way to be able to solve for x as the exponent and x as a normal variable, but that lies outside of our syllabus. So here we have to be able to look at what we've got and do this by inspection. Okay, so we're doing it by inspection. So do you remember when we're like in grade 8 and they said to us, solve by inspection? If we were given something like x plus 2 equals 3, if I asked you to solve that by inspection, you would look at the left, you'd look at the right, and what would you tell me? What does x have to be?
Oh wow!
Exactly,
I could have
exactly.
never actually thought of that.
Okay, so it's really as simple as that. It's by inspection,
Sure.
right? We're just looking at it and we're able to figure out the answer. So now, if we think about it, this point of intersection between these two graphs, what quadrant does this have to happen in? Which quadrant would it be taking place in? The first quadrant, second quadrant, third quadrant, fourth quadrant? Where would this point of intersection be? It would be in the first quadrant, absolutely. Okay, so it would be in the first quadrant, and we know that x is positive in the first quadrant, right? So if x is positive, it's got to be greater than 0. We know that this point of intersection is not going to take place on the y-axis. It's got to be somewhere in the first quadrant. So look at 2 to the x and minus x plus 3. And now by inspection, can you figure out what the value of x needs to be in order to make the left-hand side balance with the right-hand side? Anyone got any ideas? What would x need to be to make the left balance with the right? On the left, we have 2 to the x. On the right, we have minus x plus 3. What would x need to be in order for the left and the right to balance? Ah, Tlogi. Yes, good. It would need to be 1. Quite right. Good. Okay, so we're thinking of a positive x number. So 2 to the power of 1 is equal to minus 1 plus 3. So both of those would be equal to 2. Brilliant. And that's it. That's our answer. X is equal to 1. Okay, so that's why I say to you, this is an easy, difficult question, because the answer is very simple, but yeah, thinking about how we would get there is a bit more complicated. Kagiso?
So, ma'am, the objective is to just get the right-hand side and the left-hand side equal.
Absolutely. So you're doing it by inspection. Okay, there is, as I say, there is an algebraic way to be able to do it, but that is outside of our syllabus. So the only way that you would be able to do this is by inspection. Okay. Pinga, yes and no. Okay, I mean, the idea is the idea is that we never really want to be like taking a wild guess. It's an educated guess. Okay, it's an educated guess. It's not a just like a thumbsuck answer. It's an educated guess. Which quadrant are we working in? Where would the graph of 2 to the x lie? Yeah. So yeah, yes and no. How do you like that for an answer? Only in South Africa can we have yes, no as an answer. Never heard it anywhere else in the world.
Yeah,
Do we use the
it's
quadrant?
very special.
Yeah, we certainly are. I think that, knowing which quadrant you're working in gives you an idea of the sign of X, Raphael. Okay, so knowing that we were working in the first quadrant, that X would have to be a positive value. Sorry, Mihlali, I did not see your question. Let me just go back and see if I can find it. Sorry, there we go. I found it. Sorry, Mihlali, I didn't see that in the chat. Ma'am, I'm still confused about how do we identify the base exponent on the given graphs. Okay, so Mihlali, which are you talking about the graph of G?
Mikali, you can unmute and talk to us like this. It will be way faster if you want, if you like.
Okay, so Mihlali is on 6.2. Okay, so Mihlali, it goes back to this whole thing about log base, number equals exponent, etc., etc. So Mihlali, when they give you a, so for example, we were given g of x equals log base 2 to the x. That's in log form, okay? When we write it in exponential form, so this is y equals log base 2x, right? When we write it in exponential form, this is our exponent. Y is our exponent. Okay, this is our number. This is our base. Okay, so in other words, we would then write that y is equal to 2 to the x. So when we go from log form back into exponential form. So this number over here is our base. This is our exponent, which has become the subject of our formula, and our number is now our exponent. Okay, so another way of looking at that, sorry, I keep doing this. Let me just do it over here on the side. Another way of doing it would be like this. So log base number, shame you guys have seen me write this lots of times, equals exponent. Okay, so then it would be your base to your exponent equals your number. Okay, so that's how you would go back the other way. Okay, Mihlali, does that make sense? That's all we were doing. Okay, pleasure, pleasure, pleasure. All right, are there any other questions about this particular question, question 6? Are we all good?
I'm not sure if Kamorelo, oh, there we go. Yes, Kamorelo.
Sorry, ma'am, you didn't see my hand was up.
Oh, sorry, Kamogelo, I beg your pardon. Please go ahead and ask what you wanted to ask.
So, ma'am, on number 6.4, it says write down the solution to log 2 into 3 minus x is equal to x, right? elaborate the question for us? I just kind of don't understand it.
Okay, so that's what I was explaining. Did you hear what I was saying about you solving it by using inspection?
Yes, I did.
Okay, all right. So that's what I was discussing when I was talking about how you would solve this, because essentially what they're asking you to do is they're asking you to solve the equation that I've drawn the green block around. This is what they're asking you to solve. Okay.
Oh,
Okay, that's what it meant. So what I was trying to say with this particular one over here is that you in matric, you do not have a method for that. You do not have an algebraic method for that. So because you do not have an algebraic method for that, the only way that you can do that is by inspection. So by inspection means looking at the left-hand side, looking at the right-hand side, and then making an educated, and I use the word guess in inverted commas because it's not a wild thumbsuck guess. It's an educated, informed decision about what would make the left-hand side equal to the right-hand side, bearing in mind that you are working in the first quadrant where X is positive. Okay, so you now have to look at that equation and say to yourself, what would X need to be in order for the left-hand side to be equal to the right-hand side? Exactly. Yes, Yolanda, there we go. Yeah, so by using inspection. All right, so in other words, we're looking at it to get the answer. We're not actually algebraically calculating it. That's why it's only out of 1 mark. Right? And that's why it says write down, okay? Because it's not something that they want you to calculate.
okay, ma'am. Thank you. I now understand it.
No, that's fine. No problem. Okay, so if X is equal to 1, then the left-hand side and the right-hand side are balanced. Okay. Good stuff. Any last questions? There is the quiz. Thank you so much, Yolanda. Then this question over here also comes, I didn't get a chance to do this with you this evening, but this question over here is a nice question for you guys to do. It also involves a little bit of inverses. So those of you that wanted some homework, you are welcome to try this particular question. I'll just sort of move it over like that. Maybe what I must do is make this a little bit smaller. Then at least you can
Yes, I
take.
think if the graph
Okay.
can be smaller, it can
Okay,
be.
so then, all right, so there we go. And then what I'll do is I'll move over and then you can take a screenshot of the question. So there we go, screenshot the graph. Okay. And then I'm going to move over and then I'm going to let you screenshot the questions. Okay, so hopefully by now we've all had a chance to screenshot the graph. I'm going to move over and then you can see the questions as well. Okay. Oopsie, and there's part of the answers. Let me just move that out the way. Sorry, guys. Just go back here.
I don't want to be lazy and just looking at the answers and be like, oh, this is how we do
No,
it.
no, definitely not. Definitely not. Okay, so we can always give the answers to you at another stage. Here are the questions. And again, this comes out of a matric paper. They have combined grade 11 concepts with matric concepts, especially when we get to 5.5 and 5.6. Okay, so this is the sort of thing that they can expect you to be able to do.